12.9 Materials for Nanotechnology. So nano is a prefix that means a billionth. So this is a billionth of a meter. So these are particles that are in the 1 to 10 nanometer range. You can also go into 10 to the negative 10, which is called angstroms. Those two ranges kind of overlap. And so the semiconductor band gaps, if you remember that from the previous, like section 1, I think 12.1, they change substantially in size within this little range. Okay, so for instance, what normally might be yellow in macro terms might be a completely different color when it comes to a nano size. So all kinds of very, very interesting, ridiculously weird and unexpected things happen when you have particles in this nano range. So the smaller the particle, the larger this band gap. Okay, so the up here I've got the cadmium phosphide there. So on the macro level it looks black. That's the end of the arrows. Okay, the band gap is small and it absorbs most of the visible light, and it's actually black. So remember, this bandwidth that we were talking about in terms of whether something's a conductor of electricity or not also contributes to what color something is. Is a material a certain color? It has to do with are there absorbing electrons or reflecting electrons? And so since the band gap is small, it absorbs most of the light. And see, when the particle is made smaller, the color changes. Continuously it changes until no visible light is absorbed. So the band gap is so large that only UV light can excite those electrons. Visible light electron energy cannot excite them to the conductance band. So by appropriately tuning the band gap of these are called quantum dots, by the way, quantum. If you tune them, if you think of just how big you would want them, you could actually get one material to make all the colors of the rainbow. So this picture below, where you've got all the oranges and blues, all is the same material, just at different size particles. So as the particles are bigger and smaller, it gets crazy. Okay. All right, and then so finely divided metals can have different properties than larger samples of metals. So a metal, say, that's in a pigment in the window on the left, can be a different color when it is small. Okay, so finely divided can actually, so the smaller you can get differences in this case color, other properties as well. And then I think one of the most fascinating, of course, you could take an entire course. I've taken an entire course on chemistry. It's ridiculously awesome. But you can make them into like little pills, so little chambers where you can have nanotubes, or you can have nano balls or nanospheres. And for instance, you could put medicine in them. Your body would not recognize the medicine as a poison, like chemotherapy. It would only see the carbon on the outside. It would take it in like if it was food, and then you could medicate a portion of the body that wouldn't accept it otherwise. So all kinds of really, really cool things that are doing. Some of the best minds in the world right now are working in nanotechnology.